Hello everyone, that is my channel, Awad Infrastructure. In this video, we will continue with our playlist Tunnel Project Civil 3D. I will go through with this playlist. In first lecture, we have learned to create a circular tunnel section using Civil 3D. And second lecture, we learn how to create alignment and profile view for this tunnel. And the third lecture, we learned to design cross-section view for circular section, and how to compare this section with as built. And we have create a video to learn how to use Autodesk Subassembly Composer. So in this video we will continue with this playlist, and we will learn how to create tunnel cross section but using Autodesk Subassembly Composer. We have learned how to create circular tunnel assembly using Civil 3D, and I have made a simple video to learn how to create sub-assembly use Autodesk Subassembly Composer. So in this video I will complete, and I'll learn how to create tunnel cross section using Autodesk Subassembly Composer. In first video we have learned how to create tunnel cross section using Civil 3D, and someone in comments have asked me to do this tunnel cross section using Autodesk Composer. So I will answer this question in this video. This video is lecture 4, and I am gonna do tunnel cross section using Autodesk Subassembly Composer. Now let's begin. That is Civil 3D, and that is Autodesk Subassembly Composer. Now I will go through some steps. There are two components of circular tunnel segment. The first component is tunnel segment, and the second component is tunnel filling concrete. So we will start with tunnel segment, and we will deal with tunnel filling concrete. Now we will start with tunnel segment, and there are steps that we will go through in our video. The first step is to input tunnel dimension like tunnel radius and tunnel thickness. The main advantage of Autodesk Subassembly Composer is that we can deal with variable dimension. We can change tunnel radius and tunnel thickness, but in Civil 3D we deal with constant dimension. Let's get with first step. The first step is to input tunnel dimension parameter radius and tunnel thickness. So the first step is to input these two parameters, tunnel radius and tunnel thickness. To input new parameters, we will click create parameters. We'll insert radius, and thickness. We will write thick to represent thickness, and don't forget to write display name to view this name in Civil 3D. We will write tunnel segment thickness Now we have finished from first step, that we input two parameters to control dimension of tunnel cross section. The second step is to insert 3 points by radius from origin to form inner circular section. We will insert 3 points that represent the inner circular section. Let's go. We can insert this point from this geometry. First point, we'll insert it to flowchart. The first point will represent the upper corner of circular section. We can insert it by delta x and delta y. From origin, delta x will be 0 and delta y will be radius. So we will write down radius. And we will insert any default value like 4, and the same for tunnel section. We will insert 0.5 to preview this section. So we insert the first point that represents the upper corner of tunnel section. To view this section completely, we will click Fit to Screen. Now we will insert the second point, which represents right points. So we will insert a point into flowchart by delta x and delta y, the same for the previous point. Delta x will be radius. We will write down radius, and we should be careful to write this word as input parameter to be identical with input parameters, and delta y will be 0. We'll uncheck a link and click Fit to Screen. But we should do delta x and delta y from origin. All inserted point will be from origin. Fit to Screen. We insert top point and right point, and now we will do the same for third point, which be the bottom point. And now third point, delta x and delta y from origin. Delta x will be 0, but delta y will be radius. But this point will be the opposite side at down, so we will put negative sign. We'll put negative sign to be on the opposite side of P1. Now enter and Fit to Screen. Now we insert 3 points that forms in inner cross section. Let's see the next step. The next step, we will offset 3 points from the previous point by tunnel section to make outer section. We have created the inner section. Now we will create outer section to form tunnel segment. So we'll do 3 points as this point, but we will do offset by tunnel sections. First point will be offset from P1. That is new point, and it will be delta x and delta y from top point, which be 1. Delta x is 0, but delta y is tunnel thickness, which we type sec in our input parameter. So we'll copy this text and paste into delta y. Enter. The top point P4 is created by offset from B1. We will do the same for the next point, which is offset from P3. Now we'll insert the point and we'll offset from P3. Delta x is 0 and delta y will be thickness, but in negative sign because it is below P3. Negative is text, Ctrl V and enter. And there is important notice that we have unchecked this link. We keep it as market. We'll add the final point that is offset from P2. Third point, delta x and delta y from P2. Delta y will be 0, but delta x will be sec, which is tunnel thickness. Okay. But we will remove link. We'll remove link by unchecking this link. So we have created all points that represent the tunnel segment. Now we will link the inner points by curve, and we will do the same for outer points. So we will insert curve. We'll keep creation type as arc 3 points. Start point for inner will be P1. We create now inner section P1. Arc point will be P2. And final point is P3. Fit to screen. Now our inner section is ready. We'll do the same for outer section. We'll insert curve using 3 points. Start point will be P4, arc point will be P6, and the end point is, let's see, end point will be P5. Outer section is created. Now tunnel segment is ready. Now we can create shape. Basically our links are created, so we can add shape from these closed links. Let's review our steps. We have done 30 steps, and we have done 40 steps, so we will do the shape steps by clicking this and click in the space between two links. Now the shape is created for tunnel segment. Now we have finished from tunnel segment. Now we will turn to tunnel filling concrete, which is more difficult. The first step in tunnel filling concrete is the same steps in tunnel segment. We will input parameter. This parameter is filling concrete thickness, which represent filling concrete thickness. So as we do in first step for tunnel segment, now we will input parameter for filling concrete thickness. Create parameter, and we will type filling concrete thick, and don't forget to type this error. We shouldn't do space, so we will type without space. Okay, and we will type display name filling thickness, and we will enter any default value like 2. Okay, so we have finished from first step, which is inputting parameter. That is first step. Now we will do the second step, which is input top point of the layer by above parameter. We will input top of filling concrete. We will insert a point from P3, which represent bottom point of inner section. From point is as we said P3. Delta X will be 0, but delta Y will be filling concrete thickness. So we will copy this text and we will paste it in delta Y. And we will add a link from this point. So the link is created from inner bottom section to top of filling concrete. So we insert top of this layer. Now we will do the most important step, and that is we wanna join this point with tunnel segment. So we will add auxiliary point and auxiliary link to be intersected with tunnel segment. So we'll add auxiliary point and auxiliary link is created automatically. Auxiliary point will be offset by delta x from 0.7. Delta x will be in value. I will put it radius to be intersected with tunnel segment, and the link is created automatically. So we have created auxiliary point and auxiliary link, and there are intersected with tunnel segment. So we will do the next step, and the most important step, insert intersection point that joins auxiliary link and inner segment link. This step is based in the third steps, which we do soon, auxiliary point and auxiliary link. So we will intersect auxiliary link with tunnel segment. Now the next step is to insert intersection point will join auxiliary link with inner tunnel segment link. So we will insert auxiliary link 1 and link 1, which is this. That is that is link 3. We will join auxiliary link 1 and link 3. Intersection point link 1 will be the L3, and link 2 will be L1. Now intersection point is created. So we will format the shape of filling concrete. Now we will link P7 to P8 by link. We will insert a link, and we will join P7 to P8. Now we have created 3 points of filling concrete. Now we will do the last step, how to create shape for filling concrete. It is very hard to create curve that link P8 to P3. So we wanna create third point to form curvature of filling concrete. We are gonna insert third point to form curvature of filling concrete, because in Autodesk Subassembly Composer curve is formed by 3 points, not 2 points. So we will insert another point in this. So we will We'll insert another auxiliary point and auxiliary link to form curvature of this layer, like the third step. Now we will insert the auxiliary point from P3. Delta x will be 0, delta y any dimension, I put it any value like 1. We'll insert another auxiliary point that is located on inner tunnel segment. Delta x, I will put it any value like radius. And delta y will be 0. Auxiliary link 2 is created automatically. Now we will insert intersection point to intersect auxiliary link 2 with tunnel segment. Link 1 will be auxiliary L2 and link 2 will be inner circular segment which is L3. So B9 is created by intersection. Now we can create curve from 3 points P8, P9 and P3. We'll insert curve that is links 3 points P8, P9, P3. Now as you see, a curve is created from 3 points and filling concrete is ready. Now we will create a shape from the 3 links, this link and the curve. Shape, add link, and we will click in any point in this space, fit to screen. As you see, we have created our tunnel cross section using Autodesk Subassembly Composer, and we can change any dimension in this cross section. Let's try. We will change the radius from 4 to 5. Enter. You can see that tunnel segment radius is changed. Now we will change thickness by to 1. Thickness is increased. Let's go through, let's change filling concrete thickness, for example 3. So the main advantage in this video that we can control our dimension. Now let's do the last step. Our assembly is ready to be exported to Civil 3D. So we will save it. Save.
Now we have saved this assembly on specified location. Now let's turn to Civil 3D to know how to import this assembly and use this assembly in our program. Now we turn to Civil 3D. I wanna learn to how to import sub-assemblies to Civil 3D. From Insert tab, import sub-assemblies. We will search for our created sub-assembly. This that we created, and we'll import it to any tool palette like this. Our tool palette in Home tab. That is tunnel assembly that we created is imported to our program. Let's try with assembly. We wanna create tunnel cross section assembly, so we'll create a new assembly. We'll click this assembly that we have imported. This window is previewed, so we can input our desired parameter. We can change radius, tunnel thickness, and the filling thickness. That is the names of input parameter that we have typed. Radius, tunnel thickness, filling thickness are demonstrated in our program, and these are default values that we have entered in Autodesk Subassembly Composer. So we can change our tunnel dimension. We will click on center line. So tunnel segment is created for right side, and we can do the same for another side. And we can add the left half by side left, and click on this point. So our tunnel section is created using Autodesk Subassembly Composer, and it is imported to Civil 3D. But to create this second half, we should insert default value for side. We should insert default value for side to be activated in Civil 3D. Thanks for watching, and goodbye.